So just to conclude this brief introduction to the S2S forecast system for the Indian monsoon being run at India Meteorology Department. As we said, because now people consider that there is skill and useful information at homogeneous regions where the country is divided into these 5 regions. If you look at the trends and distribution of rainfall every year, it looks different, and it is rather surprising that trends tend to be also at such local scales. So the physics of why there are large-scale structures we saw in the beginning at meso timescales, active break extending from northwest Pacific to northwest India, and there is this split ITCZ with marine ITCZ staying on the ocean because the ocean is warm. There is the tropical convergence zone over land or the monsoon trough, and then there are mesos propagating in between. Even with all that large-scale dynamic features, the distribution is very uneven every year. As we said, the distribution is more spatially variable during wet years and normal years than during dry years. So people look for clustering information of droughts and so on, even though no solid information is derived so far. But people want Taluka level or 1 degree by 1 degree level information because farmers want information literally at farm scale, and there are there is work being done with farmers which reduce these forecasts of weather time scale, short and medium range, so 1 to 3 days, 3 to 10 days, and extended range out to 2 to 4 weeks, and use Monte Carlo and other statistical approaches to produce probabilistic rainfall information at farm level so that decisions on irrigation and other things can be done. Some nice studies coming out of the Indian Institute of Technology, Bombay, for example. Okay, so here is an example: deterministic skill of weekly lead prediction of area averaged JJAS rainfall with observations for the hindcast period over the meteorological subdivisions of India. So now we are not on homogeneous regions anymore, but we are looking at various state levels, and this is JJS rainfall anomaly correlation for 2003 to 2014. Lead week 1, week 2, week 3, and week 4. Obviously skill drops off, but there are some regions where skill remains above 0.5 even into week 3 here, for example. So these are sub-state levels, not necessarily at Taluka level, but they are at various meteorological subdivisions created by looking at long-term rainfall. India has very nice long-term rainfall observation started in the 1800s, so this provides a very rich way to derive information. So also puts a challenge to forecasters to match the observed distribution. Okay, so nothing unusual except that the peninsular India tends to have very low prediction skill even in week 1, almost disappears in week 2 and week 3, 4. But week 4, most of the country has very low skill, and even where there are colors, the skill is not at a usable level. But week 2, week 3 are still regions with usable skill, and people do use them. So the question is, of course, to understand what causes these contrasts. There are studies done with moisture sources and so on which explain that during the break period, for example, the Gangetic plain over here has a lot of recycled rainfall which may get contributions from heavy irrigation, for example. But during the break period, the evaporation from here supplies the northeast region, so you get this east-west pattern that we saw before. And there is also evidence that during active period Vegetation over the Western Ghats collects moisture, and the evapotranspiration during the break period actually supplies moisture to peninsular India, especially over Tamil Nadu. So these are the regions here where there is a strong northeast monsoon. Summer monsoon is much lower, so those things also have to be kept in mind. Looking at the fractions skill score, which determines the spatial scale of predictability for a given forecast lead time, FSS for the current generation forecast system for different lead times for above normal, that is active periods, and below normal, so break phases, and tercile categories are shown here. So again, probabilistic information in terms of quintiles, terciles, and so on. So the fractional skill score for 1 degree by 1 degree grid, 2 degree by 2 degree grid, and so on are shown here. So it's not the lead time for active and break periods, with lead week 1, week 2, week 3, week 4, and the target, which is here in terms of the usable skill score at that regional level. And you can see that obviously as you integrate over space, skill increases, which is not surprising. For example, if you look here, if you average over larger areas, you get increased skill for all weeks, but with longer lead time the skill drops off even if you average over a large region. And there may be systematically higher skill in the active period than in the break period. Could be just considered as a signal to noise ratio. If there is very little rainfall, then predicting that can be difficult, plus the spatial variability. So you can think of India as a popcorn kettle that is warmed. There are instabilities, and then there are kernels popping here and there. So break in that sense has fewer kernels distributed over space, whereas here you have more distributed rain over larger scales. So skill is higher here even at longer leads, and drops off faster here with longer leads, and so on. Okay, so this continues, and the attempts to increase skill of spatial distribution continues. There is an effort parallelly to understand the processes that determine the spatial distributions, which has a long way to go, obviously, because there is the role of soil moisture, vegetation, agriculture, land use, irrigation, and so on. But with regional models which downscale the forecast, it's known now that land use actually affects the skills, and properly representing the land use can enhance the forecast skill. So how do you do that in a global model? Can you just prescribe better local land use and then also improve local skills, or does it need improved land use representation all over the globe? Those are difficult questions, but nonetheless knowing that that matters is still very important.